So we're in lesson 41B, permutation notation. We've worked specific permutation problems, but we've kind of avoided the general notation for this type of problem, which is basically the formula for permutations. Now remember, with permutations, we are not allowing repetition. So we're going to subtract 1 every time we move forward. So we know how to solve this type of problem, right? We would say 22 in the first position, 21 in the second position, 20, then 19, then 18, then 17. And that would be 1, 2, 3, 4, 5, 6 positions without repetition. So every time we use one, we remove it from the available options. And then if we do the calculation, we end up with 53,721,360. I'm not that smart. It's written for me in the book, so I didn't have to actually do it on the calculator. So we recognize that whenever we do this, we are subtracting 1 from the previous number. And that number that we begin with is our n value. So it's n. It's kind of like consecutive integers where we add 1 each time. This time, though, we're going to be subtracting. So it's n minus 1, then n minus 2, then n minus 3, and so on and so on and so on until we get to the very end. And that's going to be, the number of times is going to be n minus the rate plus 1. And that's where we're going to stop. So that would be n minus whatever the rate is. And the rate here is 6 at a time. So it'd be n minus 6 plus 1. So n minus 5 would be the last one that we would do. So we'd have n minus 4, n minus 5, and we'd be done. And that's how we would calculate where to stop, right? So the last factor is not n minus r because of that, because we're not accounting for the very first one. Just like in consecutive integers, our very first one is n, it's not n plus 1. So we have to add that 1 back in so that it doesn't throw the calculation off. So the way this is noted is the permutation of the number of things at a certain rate is equal to n minus 1, n minus 2, n minus 3, ellipse to n minus r plus 1 until we get to that end notation there. Some people will say it's p number of things to the rate. Some mathematicians write it like this, and some will even write it like this, n comma r, like an x and a y. All right, so let's look at how we can do this factorially. We're going to use a factorial method to illustrate permutations, and we're going to use the same problem, but we're going to do it 41.6, and we're going to look at it a little bit differently. So factorially, we know that we can multiply 22 factorially all the way down, right? And we would get 22 times 21 times 20 times all the way until we get to the very end of the factorial, and that would be 1. But we want to stop at a certain point. So the place that we're going to stop at is our rate. So we're going to look at what that would be. So our rate would be 6. So 22 minus 6 is where we would stop. So we would do 22 factorial, actually, like this. 22 times 21. This is basically factorial method. 19, 18, 17, and then this is all the ones that we really need. So we need to account for the ones that we need to take out of the calculation to stop it. And we remember how to do that. We would say 16 factorial over 16 factorial, and then we would factor them out, right? But we need another way to do that so that it is relatable to each of the formulas every time. So we're going to do it like this. We're going to multiply this by 22 minus the rate as a factorial over 22 minus the rate as a factorial. So it's n minus r factorial divided by n minus r factorial times everything we started with. So this is permutations of 22 things taken 6 at a time, and then we're resolving it this way. So when we multiply, what we end up with is P22 at 6 is equal to, we have a 22 times 21 times 20 times 19 times 18 times 17 times 16 factorial, all over 22 minus 6 factorial, because that's what the 16 is. And then those would factor out. They would cancel each other out. So in other words, we would have 22 factorial is divided by 22 minus 6 factorial, which would be 16 factorial. Right? So 22 minus 6 would be 16 factorial. So you have, this would end up being in notation, permutation notation, you would have the number, let me use a lowercase so it's consistent. The number times the rate is equal to the number factorial over the number minus the rate factorial. And that would be how we would write that out, because that would be what it would end up being, because this would cancel that. And then we would still end up with what we originally started with, which is the 6 first permutations times each other. So let's do that and see if we get the same answer on our calculator. Let's make sure that that works. So if I have 22 factorial divided by 16 factorial, I get 53,721,360. And if I recall, on the first problem, when we did all of those calculations, we got 53,721,360. And to double check that, let's just do the permutation. 22 times 21 times 20 times 19 times 18 times 17, same number. So this works. So this is what we're going to use whenever we want to do the factorial notation for our permutations. So let's try, let's see if we can do one more. Yeah, we have one more we can do. So write that down. This is how we're going to do this. The number rate, the number factorial divided by the number minus the rate factorial. And this is going to be the best way to do that for us. It's the fastest way to do it for us. So let's clear the page and do 41.7, and then we'll be done. So 41.7 says, find 12 things, 12 permutations at 4 at a time. So that's going to be P12 4 is equal to n, which is 12, and then n minus r, which is 4 factorial. So that is equal to 12 factorial over 8 factorial. And let's see what the answer is. So that's going to be 12 factorial divided by, I'm going to open my parenthesis, 8 factorial, close parenthesis, 11,880. Well, we know what this is, so let's write it out the same way. This would be 12 times 11 times 10 times 9, right? So let's see if that's the same answer. And double check our work. 12 times 11 times 10 times 9 is the same thing, 11,880. So this works. We got the same answer, and we were able to check our work by writing it out the way that we know it needs to be. All right, that is all we have for permutation notation in 41B. I'll see you in lesson 42.